Okay, we have another work example on our series, which is logarithmic differentiation. Find the derivative of y is equals to the cube root of natural log of x. You see, before we can solve this question, I want you to note that if we have x raised to the power cube root of x is what? X raised to the power of what? 1 all over 3. You understand? Okay, now let us proceed. So I can rewrite y as what? Ln x raised to the power of what? 1 over 3. Now you can see that we have an exponent. We have ln x to the exponent of 1 over 3. It is important to know that when you are dealing with differential calculus, how this rule revolve around itself. For example, the power rule, the chain rule, the product rule. So it is very important to understand the concept. We are treating logarithmic differentiation. However, we still resort back to chain rule. So it is important to understand these concepts. Now, don't forget, in our previous lesson, I told you that the chain rule is given by this. When we are told to differentiate a function, a composite function, maybe u raised to the power of 3. This is a composite function. If you are told to differentiate short function, dy all over the x, let me put x, dx is equals to dy all over du multiplied by what? Du all over dx. This is chain rule formula. You understand? Well, and chain rule is used to differentiate a what? Composite function. Now let us proceed. In that case, I'm going to set u is equals to the function inside the bracket. The function inside the bracket is what? Ln x. So u is equals to what? Ln x. Are you following? So from the chain rule formula, which is this is the chain rule formula. From the chain rule formula, I still need to take the derivative of what? U, which is what? Du all over dx. So the du over dx differentiate ln x. Don't forget, from our basic natural logarithmic differentiation, this is the rule. If you have to differentiate ln u, dy is equals to what? 1 over u multiplied by what? The derivative of u. You understand? So now let us use the same approach here. In this case, x is what? U. Are you getting it? So dy du all over dx is what? 1 over the function inside the bracket multiplied by the derivative of the function inside the bracket, which is x. Do you understand? So du all over dx is what? 1 over x, because if you take the derivative of x using the first principle, you are going to get what? 1. Are you following? So I have gotten du over dx. From this formula also, I still need to find the derivative of dy all over du. Since I have set u is equals to the function inside this bracket, I have set u is equals to ln x, then y will be equals to what? U raised to the power of what? 1 all over 3. Are you following? You understand? Because I have set u equals to ln x. So y will be equals to what? U equals u raised to the power of what? 1 all over 3. Now let us find the derivative of y, which is what? Dy all over du. Dy over du. Now differentiate this using the first principle. Don't forget, the first principle, we are told to differentiate ax raised to the power of n. Dy, derivative of y is equals to what? The power will multiply the coefficient. I'm going to have na raised to the power of multiplied by x, and the power will reduce by what? 1. You understand? So we are still going to use the same approach in this place. For this, I'm going to multiply the coefficient of u by 1 over 3, and 1 over 3 will be reduced by what? 1. So in that case, I'm going to have 1 over 3 u, then 1 over 3 minus 1. You understand? Now let us solve this. 1 over 3 minus 1. Take the LCM, that is 3. I'm going to have 1 minus 2. That is minus 2. Oh, sorry. 1 minus 3. Minus 2 all over 3. So dy all over du is equals to what? 1 over 3 u raised to the power of minus 2 all over 3. You understand? Now I have gotten dy over du and I've gotten du over dx. So I have gotten all the parameters that I need in this formula. So dy, I can proceed to say dy all over dx is equals to dy over du. Dy over du is what? 1 over 3 u raised to the power of minus 2 over 3 all over 3 multiplied by what? Du all over dx. Du over dx is what? 1 over x multiplied by 1 all over x. You understand? Now I want you to pay attention here. If I have u raised to the power of what? 1 over 2. This is also the same thing as what? Cube root of what? U. Okay? If I have u raised to the power of 2 over 3. This is also the same thing as what? 3 root of u raised to the power of 2. You understand? So now I want to reduce this. So dy over dx is equals to what? 3 to the root of u raised to the power of minus 2 all over 3 multiplied by 1 all over x. You understand? Recall that u is equals to ln x. You understand? So I'm going to substitute u as ln x in this place. So I'm going to have dy all over dx is equals to 3 root of ln x raised to the power of minus 2 all over 3 multiplied by 1 all over x. You understand? So dy all over dx is what? If you simplify this, you are going to get 1 all over 3 root of ln x raised to the power of 2 multiplied by 1 over x. So dy all over dx is what? 1 all over 3x into bracket 3 root of ln x raised to the power of 2. So the derivative of y is equals to the 3 root of ln x is what? 1 over 3x multiplied by the cube root of ln x raised to the power of 2. Thank you very much for watching the video. Please, I want you to subscribe to this channel and like the video. Share your thought on the video. If you have any question, drop it in the comment box. I'm going to attend to it. Thank you very much.